Yeah, welcome to the CrowdScience seminar. These seminars cover a broad area of human-AI collaboration to allow discussing past and future work, exchanging ideas, and establishing new collaborations. Most tasks in crowdsourcing are focused on classification. And when performing image segmentation with bounding boxes or audio transcriptions, you need to reduce your task to classification. And at the VLDB 2021 CrowdScience workshop, the Toloka team has organized a shared task on automatic audio transcription. And today, Nikita Pavlichenko from the Toloka team will reveal deep insights from this competition. So I'm happy to bring the stage to the speaker.
Yeah, thank you, Dima, for the introduction. As you said before, my name is Nikita Pavlichenko, and I'm a researcher at Toloka's Crowdsourcing Research Group. And today I'll give a talk that entitled "Make the Best Crowdsourced Audio Transcriptions," and this is about our shared task on CrowdScience workshop at VLDB, as we said before. So we will talk about the workshop and why did we run this competition, and how we collected the data, and how did we run a crowdsourced competition, and we of course will discuss the results and scientific advantages that we achieved during this competition. So let's see how machine learning research works. Why does machine learning research works? So we in machine learning we have lots of theoretical foundations, and we have some methods and some, for example, neural networks, machine learning algorithms, and we have cool benchmarks where you can evaluate your methods and compare methods and even know that you're making some improvements. And with these things, we achieve rapid growth of the machine learning research field. So, but what we have in crowdsourcing research field. So, the crowdsourcing is a very good field to apply some theoretical methods because it's about some humans and seeking the truth. It sounds cool, and it is a practical thing that helps industry and the science. And we have a lot of methods, for example, some biasing models like probabilistic graphical models. So let's remember InfraNet from Microsoft that are evaluated on some crowdsourcing tasks, and there are many other applications from by mathematicians or computer scientists to crowdsourcing. But the problem with them is that they mostly are some theoretical methods. So they have some theorems, and of course some of them have experiments, but most of the time they are evaluated on synthetic or tiny scale data with some assumptions that maybe are not applicable in real data in real life. And we don't have a gold standard.
Okay, let's see.
Yeah. And we don't have a real well-known gold standard benchmark like ImageNet in computer vision and superglue in natural language processing, and we don't really have good benchmarks at all. And we can see that we don't have a real progress in many fields of crowdsourcing research. If you take, for example, I think the most researched question in the crowdsourcing, that is truth inference in crowdsourcing task with categorical answers, you'll see that we don't have any benchmarks that are used in all the papers that published on this problem. And as a result, we don't really see the progress. So no progress till David Skin in 1979. And to address this problem, we propose a benchmark we want to propose benchmarks for crowdsourcing methods. And we decided to start with audio transcription task. And so this is where audio transcription is not maybe not the most popular task in crowdsourcing. Yeah, most of the crowdsourcing tasks are classification, like you see on the slide. You have some unlabeled data and you want to assign a single label to every image, but it still exists on crowdsourcing platforms. And for this task, I think we don't have any benchmarks at all. So, and as we know from the categorical aggregation research, so aggregation is a very important part of the crowdsourcing if you want to obtain a high quality data. So if we want to obtain a good quality, so high quality audio transcriptions to train your automatic speech recognition system, we'll need some high quality data and high quality aggregation algorithms to train on. And so we, as I said before, we have a long line research on developing aggregation algorithms, but they mostly only can be applicable to the categorical data, as you see on the slide. But in speech, and these methods work well. So you can make some good assumptions on the preformers, and as I said before, there are no really benchmarks and gold standard benchmarks, but we have some data to use for categorical aggregation. But in case of audio transcriptions, you have a very large space of possible answers, and it's mostly impossible to make some good sounding modeling assumptions. And the most important thing, we don't have enough data available to learn insights from. And as the result, we don't have much progress in this direction. So we decided to launch a crowd science challenge that focuses on the audio transcription task on crowdsourcing platforms. And we released a first large-scale data set of crowdsourced audio transcriptions. And we asked our participants to use our data and develop novel aggregation algorithms that operate on these data. And you can use these aggregation algorithms, for example, to train your to collect the data and obtain good quality transcriptions for voice assistants, call centers, and, for example, accessibility tools that really suffer from domain shift. You cannot train a good speech recognition system only on the open source data. You have to collect your own data, and you'll do it with crowdsourcing. So this is so principal aggregation algorithms help to deal with domain shift problem. And what did we do? We collected about 14,000 sentences and passages from Wikipedia and books, and we passed them through speech generation system. And then we asked crowdsourcing performance on the local crowdsourcing platform to transcribe this audio from the speech generation system. And for each recording, we obtained 7 transcriptions. And this is our data set. We have 2 splits, one for the training, so that has about 10,000 recordings with about 70,000 transcriptions, and the test split for the competition and for the leaderboard. Yeah, let's focus on the data first. We wanted, so if you want to obtain the audio transcription data set, the first thing you will need to do is to find a good text corpus, and then only then you will obtain somehow the recordings. Maybe you'll ask humans to record the speech, or maybe you'll use a speech generation system like we did. And we decided to use very common known data sets like wiki corpus and book corpus. Wiki corpus because it's very well known, and book corpus for the purpose that books have more human-like speech. You don't have very rare definitions or maybe rare words in books. It's just more close to the ordinary human speech. And we did some pre-processing. So we removed punctuation, we removed quotes in order to get the audios that can be transcribed only in only single way. So, and to deal with this problem, we removed proper nouns because it's difficult to transcribe the proper noun that you hear for the first time. And then we obtained some corpus of sentences, and we passed them to the speech synthesis system. We used Yandex Speech Kit. It is an industry level speech synthesis tool that supports several languages and many voices. And we have listened to all these voices and picked up only those who sounds the best in our opinion. We picked 2 male voices and 2 female voices. And then we obtained the audio recordings and started our crowdsourcing annotation pipeline. We decided to follow these pipelines. We had an exam with 10 exam tasks that performers were required to pass before they can really annotate our big pool of audio recordings. And they were required to achieve a word error rate less than 40% on the exam, and only then they can do the work and earn money. And to address the quality control problems, it is the most common way how you do the quality control in crowdsourcing projects. You have some control tasks that you know the correct answer for, and you evaluate the quality of your performers on these control tasks. So it works for the categorical problems, for classification or for moderation or for estimating the relevance. And we decided to do the same for the audio transcriptions. We had control tasks, and we banned performers that had more than 30% word error rate on these control tasks. And this pipeline is really easy to implement on Toloka, especially if you use a Python library called Toloka Kit. So it's really simple. And in the end, I will show you our repository on the GitHub where you can re-implement this pipeline. So what we had as a result, the participants had the train split that contained the identifier of the audio, the transcription provided by crowdsourced performer, and they had some performer identifier that comes from Toloka. And for these audios, they had ground truth transcriptions, and their goal was to obtain somehow recover the ground truth transcriptions on the test part. And we implemented 3 baselines available in the literature. Let me briefly explain what these baselines are. The first is method that were used to combine several speech recognition systems. So it was really popular in the 90s, where all the speech recognition was statistically based. They had many different methods to do the speech recognition, and it was very popular to use the bagging technique, like in random forest. So so the authors of this method called rover tried to somehow bag several speech recognition systems, and it very similar to the text aggregation and crowdsourcing. You can imagine that every performer is a speech recognition system, and you need to combine their outputs. And this method is way old. As I said before, it comes from 90s, but there are two more methods that were developed in recent years. So of course, Rover doesn't use any information that comes from language models or from neural networks. And we have two methods called RASA and HR RASA that use Barrett language model to evaluate the quality of the transcriptions provided by different performers, and somehow that somehow estimate their skills. But so we experimented with these methods, and we see that the rover method is still the best for audio transcription aggregation. So it means that there is no progress from 90s to 2021 in text aggregate, crowdsourced text aggregation. So I think it is way under research problem. And we had 18 teams joined our competition, and 8 teams have been our baselines. And so as a result, they achieved state of the art on our benchmark, and they proposed conceptually new approaches that don't look like rover, they don't look like HR RASA, and they're completely new. So that's very cool. And we've seen lots of interest from people outside the crowdsourcing community, and we think that this is very important because when you want to research some questions that really isn't related only to the crowdsourcing, so the text aggregation is strongly related to the natural language processing, it's really necessary to at least have an opinion on this question from people outside the crowdsourcing community, because the crowdsourcing community is really small right now, and usually people in this community are not really in some deep learning or some natural language processing. So they usually come from mathematics, and so the second opinion is really important. And they achieved these state-of-the-art results by using large pre-trained neural networks like T5 and BART. So it shows in, I don't know, 1,000 times were shown that these language models are really powerful, and we saw it once time more. And our first challenge demonstrated great utility of benchmarks for the developing of crowdsourcing. So we didn't have a benchmark for text aggregation. Now we have a benchmark, and now we have new research, new methods. That's cool. So let's take a look at the solutions proposed by our participants. So I'll start with the second place. Maybe I'll cover some other methods if we have time, and I believe we'll have time for that. And the second and the first place, they share the single idea. They notice that text aggregation problem is very similar to the text summarization. In text summarization, you have some long text, and you want to extract the main idea of this text. And text aggregation is quite similar to that. You have several transcriptions, and you want to extract the correct opinion from this hypothesis. And how did they do that? They decided just to concatenate the transcriptions through this token that is shown on the slide, and you'll get a single text, and then you just fine-tune your favorite text summarization model. For example, the second place decided to pick the T5 large and achieved the really good improvement from the baseline. You see it on the right side that Rover had only 92 of word accuracy. So it means that transcriptions that are generated by Rover have only 92% of the correct words. So 8% of words are incorrect in these transcriptions. And the second place improved this result on 3 absolute percent points. So it's really cool. And it's a really big gap. So you usually don't see these gaps in machine learning research papers. So that one more time shows that benchmarks are important. And the first place solution is really similar, but have some good improvements over the second place. They decided to pick a BART large, but they tried T5 too, and they obtained almost the similar results. But they proposed a regularization technique to train text summarization models. If you look at the text summarization as a text aggregation, you will see a problem with this approach. Usually, we want our method to be, as we say in machine learning, permutational invariant. So it means that if you change the order of the transcriptions, so nothing will change if your model is permutational invariant. But with text summarization that is directly applied as a text aggregation, you won't see that. Of course, if you shuffle transcriptions, the model will think that this is a completely different text, and it could generate a completely different output. And in order to regularize that, the first place authors proposed to shuffle the transcriptions during the training procedure, and during the inference, you can shuffle them. For every permutation, you get the output, and then you will pick the most popular output from these permutations. So this is some, it's not really pretty, but it is really smart idea. And of course, maybe there is a big room for research. Maybe you can train your model, and you can ask it to be permutational invariant. We don't know it still yet if it is possible or no. And as I said before, if you have time, I'll say something about other methods. So there were really interesting methods. For example, it was possible to beat the baseline using really not very smart techniques, but yeah, they are smart, but they don't use any machine learning at all. So, for example, you can pick the Levenstein median transcriptions from the hypothesis, and it works well if you filtered your transcriptions in order to exclude the performers that are really spammers. And this was the 6th place, so no machine learning at all, and improvement of the baseline. So I think it's cool. And of course, all the solutions that have been Rover are some kind of cool, and for the third place, I think if I don't missing something, maybe it was the third place or the fourth place, they achieved the better result using crowdsourcing. They annotated additional data on Toloka because we offered them a promo code for Toloka. They annotated the additional data, and with this additional data, they achieved a good improvement over the previous solution. And so let's look at the food for thought. As I said, the first observation that the winning models are not permutationally invariant. And the second thought, and on this slide is observation one, usually on crowdsourcing platforms, annotators annotate multiple examples, and they have different skills. So not all the performers are equal. Some of them are experts, some of them are spammers. And T5 and BART doesn't use this information at all. So they use only the transcriptions. They don't use performance identifiers. They don't know anything about their skills. And we know in crowdsourcing that if we will somehow include these skills into model, we will achieve better results. For example, look at the skin algorithm that overperforms the majority vote. So it's clear. So there is a big room for improvements. And observation two, the best aggregation methods for categorical data succeed both simultaneously estimating correct answers and performer skills. So it's also a cool observation, and it's clear that if you use some skills and treat performers differently, you will, I think, get better results. So, and some of the participants said that they tried it, but they didn't have time and resources to do this research, because if you try to really change the T5 model, you're likely to retrain it on a big data set, and it wasn't possible in the conditions of our competition. So as a result of our competition, we published 2 papers, and we uploaded our resources to very famous hubs. We additionally annotated the LibreSpeech dataset of audio recordings. It wasn't possible to use the audio transcription dataset for the competition because it will, of course, lead to a data leak. But for the publication, creating a benchmark, it is possible, and we did annotate a LibreSpeech on the Toloka, and we named this dataset as a CrowdSpeech dataset. And this is also a large-scale dataset that is even larger than dataset we used for the competition. And you can find a benchmark on Papers with Code, where all the machine learning benchmarks are posted. And we think that will lead to maybe greater achievements for the crowdsourcing community. And we uploaded all our models and all data sets on the Hugging Face. So we believe that it will push crowdsourcing researchers to use good benchmarks and to evaluate their methods on these benchmarks, and we will get better aggregation algorithms and better ideas. How can we improve things in crowdsourcing in future? So it was way it wasn't really long presentations. So I believe that, and I hope that you have some questions, and of course I'll be happy to answer them. Maybe Dima could start. I don't know.
Yeah, thank you very much for the great overview. I have a few questions and we can start with mine. So I believe what is really interesting here for me is the following. What do you think? What if we, or not we, if someone uses a not fine-tuned model? So the problem is, if you fine-tune your model on the specific data set, it will be fine-tuned on this specific data set, and it probably will not generalize to the general sample, the population. And is it possible to address the audio transcription task without any fine-tuning?
Yeah, of course, you can treat as I said before, you can treat text aggregation and text summarization, and you can then directly apply the model that were trained for the text summarization without any fine-tuning to the text aggregation. So it means that you can take a vanilla T5 large model and apply it and evaluate it on our benchmark. And it will work, and it will work in the most interesting thing that it will work better than Rover. So language models without any fine-tuning beat the crowdsourcing community baselines. But with fine-tuning, it will be better. And the fine-tuning procedure is not really heavy. You can fine-tune T5 large on, I believe, any machine with a GPU. So, but without fine-tuning, it will work too.
Okay, good. And I've seen that in the system descriptions that some of the models did take into account the performer characteristics and some didn't. Is it correct that the best model possible will take into account the performance characteristics? It will perform this text summarization task, and it will obtain additional data from Toloka to check the hypothesis. And have I missed anything more? What's the more ideas?
More ideas about what?
So I believe every method that has beat and Rover has certain specific properties. Like somewhere text summarization was done, somewhere Levenstein stuff has been done, somewhere Toloka labels have been achieved. And what if we combine every trick we have seen so far? What do you think? Will it help the final result?
I think it will have the final results. As I said before, some of the methods that have been in Rover used performance skills, and by the winners didn't. So, of course, I believe if we combine the ideas from all the methods that have been baselines, we will achieve better results. And as before, there is a big room for improvements for these methods. So the winner model is not really, so it is really possible to make some improvements on it.
And in the chat, there's a question. I will read it out loud. What reasons could be that there was no improvements to the 30 years old model from the 90s?
So it's really difficult to answer this question because we should know some history of science to answer this question. But in my opinion, I believe that there are several reasons that there were no improvements for 30 years. The first thing is that crowdsourcing community is really new and now it's growing fast. So in 90s and maybe in early 2000s, crowdsourcing wasn't a hot topic. So if you're a researcher, it's strange to do something in crowdsourcing, because I think we even didn't have any crowdsourcing platforms. So no Mechanical Turk in 2001. And the second thing, of course, that they didn't have a benchmark. So if you want to develop a text aggregation method, you could be a really great, I don't know, machine learning researcher or machine learning engineer, but usually machine learning researchers want to improve some baseline on some benchmark. So, and if you wanted to, I don't know, develop some text aggregation method, you, I don't know, just Google text aggregation benchmark and you don't find anything. And how can you evaluate your method if you don't have a benchmark? So it's impossible. And I think it's more maybe interesting that in recent years we had some research on this, like HR Rasa, and I believe after we published our benchmarks, so there will be more improvements. But so to generalize, I think the lack of benchmarks was the main reason for no improvements.
Yeah, I think I can add a few comments here. It will be pretty difficult to propose a crowdsourced audio transcription aggregation model in the 90s, because microtask-based crowdsourcing was popularized in 2001. Well, you cannot you can't directly improve the crowdsourcing methods because there was no such a thing as crowdsourcing.
Yeah.
But the funny part about the rover method is kind of history and the publication activities and the things that are published in the conferences and workshops. At the beginning of the at the beginning of the talk, Nikita mentioned the baseline called Rasa, which is a method that also takes advantage of the large-scale language models to produce crowdsourced sequence aggregation. Exactly what Rover does, exactly what other methods in this shared task did. And it's difficult to understand why this method actually offers worse results than Rover. It does offer reliably worse results than the method from the 90s, even though it uses very sophisticated language models.
So, yeah, I can add a comment here.
Rasa was invented back in 2020.
So, yeah, let's say a couple of words about Rasa and HR Rasa. These methods were developed to aggregate the machine translation tasks outputs. So, and the specific thing about these methods is that they take into account a text similarity measure. So, and of course, if you develop method to aggregate translations for the text similarity, you will use a measure from machine translation field. For example, like BLUE or GLUE or Meteor, I don't know. So, and these metrics are not really correlated to the ones that are used in audio and speech recognition. So, and we noticed that if you will change the measure in these algorithms, for example, you replace the BLUE by word error rate, they will be you'll get better results from these methods. And with carefully tuning the guide parameters, you can beat you can also beat the robot for the aggregating the audio transcriptions. So, but we didn't do this because we just read the paper and implemented the method that is described in the paper. So if we change something, it will look like we, I don't know, developed a new method. So as these small changes in machine learning community often are treated as a
Yeah,
completely new methods.
yeah, absolutely. But when it comes to Rasa again, it's a classical example of a retrieval method. And retrieval methods do not produce new sequences. They select only the best sequence out of the available ones.
Yeah.
So if none of the transcriptions available provided to the particular recording contain the correct response, Rasa will not be offering the correct output. So, and we see clearly that in this shared task, the methods that generate new sequence based on the existing ones produce reliably better results, consistently better results than the ones that don't. So retrieval methods are not in favor in this task, probably.
Yeah, of course, it's clear that you can imagine some ultra deep neural network that can generate the correct transcriptions from completely wrong ones. So, it's theoretically possible. And the retrieval method cannot generate a transcription that is better than the best one provided for in the overlap. But I don't think that retrieval methods are, I don't know, somehow limited by the results obtained by HR Rasa. Of course, you can implement better retrieval method than HR Rasa, but of course, methods generate completely new transcriptions. I don't know. I think that they look like more perspective.
Thank you very much. Okay, more questions maybe in the chat or maybe using your microphones. Let me check the chat. I think no more questions. Let's wait for a few seconds. Maybe someone is just typing. But I think it's a very important result. So this shared task did improve the state of the art in the crowdsourced audio transcription, and it's super oftenly observed task in crowdsourcing. It's amazing to have these results here and now. So I'm really impressed of the result we have seen today. Okay, I see no more questions in the chat. I hear no more questions using Zoom. So I believe our seminar is over. Thank you very much and have a nice day.